Hi, everyone. Thank you all so much for joining. We are right on time at 10 a.m. CET, and we'll get started right away. So my name is Bella from the FJD Dynamics team. I will be the moderator today, and I'll introduce the guests as everybody gets situated. So Jacob Kalaska is our honored guest today. He is a licensed land surveyor and 3D scanning enthusiast and specialist who's been working with our product, the FJD Trion S1 scanner, for over 6 months. He'll share many valuable tips from his years of experience working as a surveyor on how to best set up your scanning missions for both indoor and outdoor projects of various levels of complexity. Dennis Chung is our very own FJ Dynamics project engineer who specializes in 3D laser scanning and point cloud data processing. He will introduce our solutions and general tips on how to optimize scanning results. Now, just a few housekeeping items before we get started on the actual content. We will be recording this webinar and sharing a link with you all via email afterwards, so don't worry about taking notes or taking screenshots. There will be some time at the end of the session for questions and answers. During the session, if you have questions, feel free to pop them into the chat box on the right of your screen, and we'll try to get through as much as we can at the end. If we don't manage to get your question answered, feel free to send an email to geo.mkt@fjdynamics.com. I'll send this into the chat box later as well. Finally, a survey will show up after the session ends, and we would really appreciate any feedback you have. This will help us improve our future content offerings. Now let's jump into the agenda for today. First, we'll do a little bit of introduction on what is 3D laser scanning. Dennis will take us through the different forms LiDAR scanners can take and share some general principles and best practices that are very helpful in ensuring that you get the best results possible. After this, Jacob will tell us some of his experience and his tried and true pro tips over his years of working as a surveyor. And finally, we'll get to the Q&A session. Now, without further ado, Dennis, please take it away.
Thank you, Bella. Hello, everyone. I'm Dennis from FJD. And first of all, I would like to introduce to you guys about LiDAR scanning solutions in different areas and different formats. So first of all, we will have the terrestrial LiDAR scanner on the left-hand side, which is the traditional way to set up tripod and do the 3D LiDAR scanning in just a minute or for one setup. And then we'll need to move on to the next location to do another scan, which takes around like hours or days, depends on your project area size. And we have the mobile LiDAR scanning device, which could be the S1 and P1. So it could be a handheld LiDAR scanning device. Also, you can install it on a drone or install it on a car-mounted device. And lastly, you can put it on a backpack so that it can help you to do the LiDAR scanning in different areas and also different scenarios. So about FJ Dynamics solutions, you may ask questions like, why FJ Dynamics? So first, I will tell you a few points about our strength in our LiDAR solutions. We pride ourselves in creating everyday tools for professionals like you guys to capture data accurately and efficiently. Our scanners are designed to be portable and flexible, just like P1 and S1, you guys can see, so that you can get the data you need without hurting your wallet and also yourself out there in the field. And we will have the workflow overview here to let you guys know a little bit more about how we walk through all this kind of scanning and processing data, and eventually outcome. We have the data process that we get for other applications. So on the left hand side, you can see we will either use P1 or S1 to capture the data first. While we are monitoring the point cloud in real time, you can monitor it on our phones or any device that's connected to the scanner. Then in the middle part, we will download the data and process it in our point cloud processing software called FJD Trion model, so that we can manipulate the model to create deliverables such as what we need. We might want to chop out the project areas, we measure the areas, volume, or even you would like to generate some floor plans or more refined dense point cloud model. Finally, on the right hand side, all those kind of data we captured will be processed, and it can be processed in other software, for example, like Autodesk Revit, AutoCAD, MicroStation, or whatever BIM model software that you guys are using. We've recently launched the FJD Trion P1, which is a very integrated scanner designed for both professionals and people who are just getting into the 3D scanning field. Both S1 and P1 offers accuracy levels up to 2 cm. But this is very conservative, as under ideal circumstances, the P1 can actually acquire data up to millimeters level accuracy. Here's a side-by-side comparison of the main spec of these two devices, and the main difference between the two of the P1 and the S1 in our experience is the range and portability. The S1 offers the longer scanning range and longer operating time, while the P1 is much more compact and portable without any compromises in the data quality. So now I'll let you guys know how to optimize the scanning result with both of our S1 and P1. Here are some key principles to remember for any 3D scanning projects. First, you need to make sure you plan ahead, and you will thank yourself later before you do the scanning. A simple walk through the project area before you begin the scan can help you identify areas that might create some challenges to the scanning missions and save you a lot of time and rework. Second, you would like to avoid people or moving objects because larger sensors and SLAM technology, SLAM algorithm do not like movement. Keep clean and clear of moving objects or people or vehicles so that you can scan for the best result. Third part is both S1 and P1 actually contains an inertia measurement unit as known as the IMU that can help the scanner understand where it's facing, the angle, and the orientation. So that's why it's important for you to initialize the scanner on a flat surface so that at the beginning of the mission, it can register the correct information to avoid errors in the final point cloud model. And you would like to have loop closure. Some of you guys may already know what's called a loop closure. So even though it's big areas or smaller areas, you would like to have this kind of actions. Loop closure is important concept so that we will revisit in just a bit, but as you can plan your mission, it's important to keep in mind that you need to capture the data with meaningful overlap so that the point cloud model registers correctly. And finally, even though both S1 and P1 have powerful SLAM algorithm to help them process the data accurately, it's safer for you guys to transition slowly and steadily between spaces to save your time and effort in the post-processing adjustment. So before you guys do the scanning, you will always like to check your equipment to make sure everything is in good form, good shape, in working orders. You can use the air blower or a soft cloth to clean the scanner head before you do the scan. Also, take a walk through the site, the scanning area, to make sure, take notes, or know there could be some challenging areas, and plan your route before or after you do the scan so that it will be helpful for you guys to mark some physical or digital floor plan if you have access to one of them. Of course, secure anything that might be moving around like doors, people, or even anything that's movable. Communicate with the on-site team so that you can do the scanning and ask for their permission or cooperation either in cleaning out the site to make sure you're safe during the scanning. So here are some potentially challenging environment, as you can see on the screen. You like to try to avoid the scanning areas that contains large amount of glasses or mirror, or it could be some similar structures. For example, like long corridors with uniform walls and floors. This kind of area is kind of challenging for the scanner and the SLAM technology. And large opening space without any buildings or objects that's around the scanner and your project area. So this kind of areas and environment is also hard for you to do the scanning. So make sure you clean the area during the scanning initialization and also point the LiDAR towards a feature-rich environment. And lastly, don't scan areas with moving people or vehicles like crossroads or plaza, just like the bottom left picture. You'd like to have some scanning better result for the right bottom photos. Well, here we have a visual recap of our general recommendations that I've just mentioned. We'll show this video to you guys and of this presentation afterwards so that you can refer back into this kind of tips. So just like what I've told you guys, I will talk a little bit more about loop closure. So LiDAR sensors accumulate errors as times goes by, and loop closure involved in revisiting a known location during the scan and allow the system to correct any accumulate errors and align it with the new acquired data with the previously captured data to minimize the drift or any errors might occur in the scanning result. So that's why we recommend segmenting a large space into multiple smaller loops that overlaps with each other, such like what we show on the screen. There's a blue circle that we closed loop, a pink one, a darker blue, and also an orange one, to make sure that you have different kind of loop closure and overlap together, and make sure you scan at least one large loop around the parameters of the space you are scanning to ensure the data is good and the results are in good qualities. So here's a screenshot of what might happen, or you can see on the screen on the left-hand side is a less ideal walking trajectory that result in a point cloud drift. So on the right-hand side, we actually marked the trajectory with a better way to do a scanning and create a closed loop for this particular space. Starting at the red dot, going from dark pink and then to a lighter pink at the end is like a white color arrow. So in this kind of format, it actually has the loop closure. And the result is obviously, you can see on the screen. The loop closure result of this is a comparison of scan of this exactly same space, one with a proper closed loop and the other one without. And I guess you can guess which one is this. The left-hand side is less ideal because we can see drifting and also different kinds of different layers of wall. And so on the top left-hand side, you can see there's two lines on the same wall, which is obviously not right. On the right-hand side, which is the correct point cloud, which we did the loop closure correctly. So that's why we have the better point cloud result. So moving on to the corridors and narrow space, there might be some tips that you guys would like to know and make sure you do that during your scanning progress. So the general recommendations is to identify this kind of area beforehand, like before you do the scanning, and scan them separately from your main scan so that just in case if it is hard to have the loop closure or any scanning result error may occur during this kind of corridors or small rooms, you can avoid it to like damage your original main area of scanning. So it's also important to understand the field of view or FOV of the scanner you're working with. For example, with the P1, it's best to hold it almost horizontally so that the LiDAR head can see more of the space and get a featured richer environment while it's doing the scanning inside this kind of corridor. So here's a very direct comparison of how the point cloud will look depending on how you hold the scanner. As you can see, the first way of holding will give you more points and better structure. So during this kind of transition, you will also, for example, like transferring from a room A to room B, you like to wrap this up with the a better angle of the point of view so that make sure your LiDAR, either P1 or S1, is usually pointing towards a feature-rich environment. So while you are doing this kind of transition from like area A, area B, or room A, room B, you would like to do this kind of practice and make sure you guys do it daily or weekly to make sure you keep in mind this kind of concept. So to wrap this up of my portion of this webinar, I will hand the floor over to Jacob to share some tips of his specific tips and some of his use case he's getting into like for this past 6 months. He's really good at this, and you guys stay tuned to what he said and tell you guys. Thank you.
Okay, thank you, Dennis, and hello, everyone. Let us talk more about what does the scanner and the SLAM algorithm not like. I mean, which scenarios can pose problems and what leads to the bad scans. Definitely, as Dennis said, these are small, tight rooms, like toilets, for example. Keep in mind that the S1 scanning range starts from 50 centimeters. In this case, the toilets. I advise using a real-time point cloud, which is based more on trajectory from IMU unit than on SLAM algorithm in post-processing mode. Real-time point cloud is not as dense as process point cloud, but it should be enough for those small spaces. Please scan these areas separately from your master scan, like corridor or big room, and then register together. You can even use control points. This is the Trion scan function. Control points from process point cloud, which in fact could be bad and misaligned, to register the real-time point cloud with your master point cloud, your master scan. Secondly, scanner doesn't like scenarios with narrow, long corridors and repetitive rooms on sites. Please split project into many short scans and stitch them together by means of recorded control points, or alternatively features like room corners. Make sure that the walls of the site rooms are not pulled to the walls of the corridor, which may occur. That happens often when the walls are thin, that they are pulled to the corridor. Thirdly, outdoor scenarios are usually problematic for any scanners. I mean, like large open areas without features, without building and trees in proximity. I think in this case, FJ Dynamics Backpack and RTK assisted mapping is the only solution to do this properly, this scenario, to handle these scenarios properly. Okay, now I would like to give you a few small but important tips about the scanning process. Firstly, consider useful small equipment, door stoppers, to prevent doors from closing during scanning, and you'd better have plenty of them. They are cheap and very, very useful. Painter's tape is used by me to stick checkerboards on walls. Also, I use small stickers with crosshair to mark ground control points, which I use a lot. I really advise you to walk slowly and really slow when approaching another room. 320,000 points per second, it's a lot, but not so if you move fast. Okay, the next one, this is maybe a pro tip. Those of you who are familiar with terrestrial laser scanners and cloud-to-cloud registration, imagine that you have to do cloud-to-cloud at every step you take with the previous one. So avoid sudden movement and think of continuity of your trajectory. If possible, cover mirrors in some way beforehand, before you start the scanning, and keep in mind what scanner saw at your previous step, and then you plan your next step. Next case, move smoothly and turn around slowly. Generally, I avoid turning around in small rooms. This leads to bad scans. You'd better get off backwards. And another piece of advice is related to this. From my experience, it is good to walk backwards and walk sideways. This may seem stupid, but in this way, the scanner sees the areas previously scanned and the new room at the same time. It's very useful to walk backwards and sideways in the harsh scenarios like small rooms and narrow corridors. Very important. Point scanners to areas with plenty of features. As Dennis said, that demands planning of scanning path. The planning is crucial. Do not rush. You would waste more of your time to repeat scans rather than on your slow pace. Stop often and let the scanner catch enough planes in every dimension. This counts especially, again, in narrow corridors, large spaces, and in front of doorways. For example, when approaching a room, when transitioning to another room, stop for a while once you see its two perpendicular walls and the floor or ceiling. Simultaneously, the scanner sees walls of the previous room and can stitch them together properly. Then I usually stop again for 2 seconds when I stand in the doorway. This is the best way to transition the room. Stop before you get to the doorway and then stop in the doorway. Okay, record start point and end point and check if they are the same after processing point cloud, after point cloud mapping function in Trion model. I use it for first check if the scan is okay. If the start point and the end point differ no more than 1 or 2 centimeters at each coordinate, probably usually the scan is okay. Of course, it means that you have to mark the starting point and you have to get back to the same point at the end of your scan. Okay, next one. Divide project in smaller areas with big overlaps. Redundancy can save your project. And last but not least, I advise using a control network, ground points or checkerboards, someone call it chessboards on walls. Perfect if they are measured with total station. Okay, now some tips for registration process. Firstly, clean point cloud before registration. I mean, rough cleaning. Especially clean points behind the windows. They usually have very low intensity value, like 0, 1, 2, 3. You can use special filter for this in third-party software like Cloud Compare, but I believe that this function will be available in Trion model soon. Also, cut out areas with very low point density. Thanks to it, your registration will improve. I have already talked about this. Use targets for registration individual scans and use control network for high accuracy scans, for high accuracy project. It is very important to spread your targets evenly on your object, like on the perimeter of your object. And during registration, don't believe in root mean square error statistics. Always check registration with profile function. This is a really nice and useful function of Trion model. The profile, you can easily check the wall thickness and check if they are double layers of wall or ceiling. Okay, next one. If possible, place the targets in the direction where your scanner will point alongside the scanning path. It's not good to turn around your scanner like 180 degrees to catch the target. So again, you have to plan putting your control points with planning your trajectory. Okay, I believe this is it, and we can move to another section. We have the case studies. The first one is 4-story house. Is there anything specific about this relatively small project? Actually, yes. It was scanned for 3D modeling purposes, a BIM model, so it demanded reasonable accuracy, meaning wall and slab thickness, for example, should be right. Notice that the connection between each floor was through a small and narrow staircase. So to prevent from twisting levels, I had to control each floor separately and transfer separately to single coordinate system. As you probably guess, I did it by means of control network. I'm a surveyor, and these were checkerboards placed on the perimeter of each floor. This is very important to place on the perimeter in every axis. In this way, you can control every coordinate, you control levelness of your scan. And these checkerboards were stick to the windows on the glass and were measured with my total station from the outside. And you can see that the results were actually outstanding, less than overall accuracy, less than 2 centimeters. Okay, next one. Yes, this is the church. You can see nice animation. And this project shows how good looking your point cloud can be if you use 360 colorization camera with your FJD dynamic scanners. It works especially well in this kind of buildings where features are neither too far nor too close to the scanner. My general advice for colorization of any project, but especially the heritage buildings, is to avoid bright light. So you can probably scan it not in sunny conditions. And please combine multiple different scanning paths to have the best coverage. You can walk one path clockwise and another counterclockwise. You can mix different scans to achieve the best results. Please, next one. Okay, this is me wearing a backpack solution for RTK assisted mapping. You can read some basic rules for this. I will add one more thing. Keep in mind that you generally scan objects behind you. So if the scanner is on your back, so you have to really think of your scanning path again. And please try to maintain the fixed solution during the whole scan. If you can't achieve the fixed solution, you'd better scan in handheld mode and then connect this scan to the scan made in assisted mapping mode with RTK. And the next showcase example is also made with this solution. This is one of my projects where I use backpack successfully. These are monthly surveys. So in case you cannot use drone photogrammetry for some reasons, like flight restriction, this solution will give you very nice, repeatable results. So you can calculate volume in Trion model directly, or you can easily import point cloud to your favorite software. I used Egisoft Metashape, which I am very acquainted of, but you can use Autodesk Saville or any other software. So generally speaking, backpack mode is very effective for volume calculations. We can move to the next one. Here's the bridge. This is a nice example of using Trion S1 scanner for topographic measurements as a replacement for a total station and GNSS rovers. I believe it will happen soon that the surveyor would use scanners rather than total station GNSS rovers for many jobs. On the slide, you can notice that you can easily control H or Z coordinate of your project with independent measurements. You just import TXTag file and the Trion model shows you H, your height deviations. This is really nice feature, which I like very much. Why it took 2 or 3 hours? I walked up and down each side of the bridge, and then I walked around the bridge heads to get the best overlap, to the best coverage of the bridge. So it was quite a lot of walking. Another small tip, try to scan early in the morning or in the night, because cleaning the point cloud of people and cars, it's a nightmare. So to scan in the city, the best time is the night. And of course, you will get the best results when having fixed solution all the time. Okay, that's all I need, I think. Oh, you can see the slide of accuracy verification. This is what I said. Controlling of H coordinate, Z coordinate. These were very, very good results. This is automatic process. You just import TXT file. These points were measured with GNS cover to control the H accuracy. Of course, the whole project is transformed to a local coordinate system. The surveyors will like that feature very much. Trion model has implemented a lot of European or Asian coordinate systems, which is, well, this is the crucial for surveying work. Okay, show me the next slide. Okay, questions from the audience?
So thank you so much, Jacob and Dennis, for the very helpful practical tips. I hope everybody listening found the session valuable as well. And I see a lot of audience members have asked questions. I think the first one is regarding the closed loop on the bridge. How did you close the loop on the bridge? Jacob?
Generally, if you use backpack solution, you do not have to close the loops, but I did it anyway. I just walked one side of the bridge up, and I just get back the same way to the starting point. But the RTK solution, if the fixed solution is maintained through the whole scan, it helps you to do the right scan without closing the loop.
All right, thank you. And then another question from Nick. Are the control points used to register the scan missions measured with the total station? I think yes, right?
Yeah, that's right.
We do have some, yep.
You can use control points, recorded control points, if they are not measured with total station, but it helps you to stitch two scan together, but it won't transport your scan to the coordinate system. So if you are acquainted of using total station, just use it. You will get better result, better control of your work, especially if the work demands high accuracy.
I can also share a little bit more about the control points in different areas. So as you may know, I'm in Hong Kong right now, and we have our own coordinate system. And according to different government regulations, you might have different requirements for different projects. So just like what Jacob told you guys, if you would like to have more a better accuracy, sometimes you might need to use total station. But then it depends on the area and the projects. For example, in Hong Kong, we have lots of tall buildings around the cities. Then sometimes RTK might not be very good solutions. But then in open areas, RTK will be a better solution for you guys. So in
Yeah,
various you can,
I am an engineer surveyor, so I am used to the total station, but you can also use RTK rover. And if the project does not demand very high accuracy, like tree scanning, forestry scanning, you can use scanner without control points, without total station, of course.
Yeah, we have also received feedback from other customers that use, for example, a laser level indoors for creating a control environment. Once the solution is more tested and verified, we will share additional ways you can better control your scans as well with our wider users. Now we have two questions from Carol. First one is, can the software do the classification of the point cloud? The answer is yes. I don't know if Dennis or Jacob would like to expand on that for using FJD Trion model to classify the point cloud.
You can classify ground points that in the outdoor environment, and you can use walls and ceiling or floor classification in the indoor scanning if you need it.
Yeah, and I can add a little bit about that. So we have the tree survey module, which helps you classify the trees out of your point cloud. And then it can identify, for example, the tree height, the DWH, or the crown width of the tree, and then generate a report for your tree survey report. And you can submit it to, or get those kind of data in an Excel or CSV format. And yeah, that will help you do this kind of analyze or classification work.
Great. And then the second question from Carol is, can the scanner penetrate the vegetations? I think it depends on the density of the vegetation, and we have seen users combine data from the handheld scanner with drone surveying data to capture everything. So you have the ground level data as well as the overhead level. I don't know if Dennis or Jacob have more experience with here.
The SLAM scanner, it's not LiDAR scanners like those used from drone or the aerial scanning. This is different equipment, I think.
Right.
So it won't replace your LiDAR scanners like rig scanners or DJI scanners, airborne scanners. This is different equipment.
Yeah, so it's not
but
multiple.
Of course, scanning from close range when wearing a backpack, you probably your points you get the ground points as well.
Great. And then we have a couple of questions from Johan. The first one is, can you talk about how to recuperate a loop that has problems when calculated? In other products, we can tweak certain calculation parameters. Is there a way to recalculate?
Yeah, I can share a little bit more about that.
Yeah.
In our experience, once you have do the closed loop in real time, if there's any errors occurs, you can still put it inside the Trion model to do the post-processing algorithm to redo or like do a better algorithm to create a 3D model, to construct a 3D model. So in that kind of sense, yeah, we actually have two algorithms. So the real-time one and also the post-processing one. So if there's any error occurs during the first closed loop you have done, then you can still put it inside, download the FJD SLAM file and then put it inside the Trion model to like do it again and then see if it works out. Yeah.
Jacob, do you want to add to that?
No.
Okay. And then the next question is, can you talk about how the rectification tool function in model software works?
It works well. It's for, I believe, simple rough elevation control of your project. So if scan of your house level is twisted, so you can in one click make it leveled. So this function works very nice. So of course, if your scan is big, if it's a large area, you'd better use control points, of course. But this rectification feature is very useful. For example, you have if you have a scan a single apartment, you don't need any control points. You just use the rectification function to make sure that your walls are vertical and your floor is horizontal.
Great. And then the next question is, can you explain why a loop would not come horizontal, not horizontal? I'm not sure I understood the question. So maybe Johan can rephrase it a little bit and then we'll get back to you. And then another question from Adam to Jacob. I have a question for Jacob about control points on the windows obtained by a total station from the outside. What if there are double glazing windows and the coordinates do not match the inside? Are you using a vector to correct the coordinates for inside scanning?
I did some tests. I generally try to measure this point, put it on the window in perpendicular direction. So I try to put my total station in front of the straight perpendicular line of the control point. I noticed that this is slight, very small difference. That's not. It's not so important for SLAM scanning because you expect the accuracy within 1 or 2 centimeters. So millimeter discrepancies are not valid. So of course, if the glass is doubled, you'd better avoid this, and you have to think of another better way to put the control points. You can just open your windows or have a control network inside the building. But I noticed that putting checkerboards on single glass windows is okay.
Great, thank you. And then some clarification on the previous question. Some of the loops coming in from the scanner have problems with horizontal or vertical skewing, I guess, meaning that my ground is not level or my walls are not vertical. I think this comes down to a couple of different best practices. First, when you initialize the scanner, you let the IMU register correctly. So it's better to have it on a flat surface when you initialize. And then when you scan, obviously try to keep it still, not shake it too much or suddenly move it around or wave it around. Jacob or Dennis, do you have any experience with this problem and any suggestions on how to avoid?
I also advise do not rush in putting in starting your scan. Wait 30 seconds. I usually wait 30 seconds to let the scanner collect a lot of points from the starting position. It helps a lot, and of course move smoothly. And the transitioning the rooms is the key, is the crucial element of your scanning, because you probably get misalignment when transitioning rooms improperly. Sometimes it's not easy because your scanning object won't be very easy every time. So probably even if you plan your scanning path, you probably get some unexpected accidents, like people crossing your trajectory or something.
I would like to add a little bit more comment about that. So for vertical adjustment, when you close the loop, it doesn't align with the starting point and end point. It might occur when you didn't close the loop correctly. So what I mean correctly is in the best practice we usually try to close smaller loops first, and then eventually we have a larger loops. So if you just didn't follow that part, and then might be you have a super large loop and then you try to close it, it might have those kind of errors. So that's why it's the best way to plan out your scanning trajectory before you do the scan, so that you can have smaller loops and then have another larger loops to make sure you cover the whole area. So in that kind of sense and that kind of practice, it will improve your scanning result, and yeah, that will help you to get a better quality of 3D model.
Split your object to smaller scans, and try to scan the most difficult parts at the end, like cut out the most difficult rooms, maybe the smaller one, and then try to scan it separately, and maybe if needed, use the real-time point cloud, as I said in the first tip. As you, for small rooms like toilets, I usually use the real-time point cloud.
Great. And then we have another question. Will static scans and slow movements of the SLAM system increase the accuracy of the scanner?
In my opinion, yes.
Are there any tips and tricks that people should keep in mind when doing this?
Well, this smooth movement, stopping for a while very often.
Mm-hmm.
Well, for me, actually, he already described the best practice, which is walk slowly.
Yeah.
And then in case there might be some areas that might not have the reach feature, you try to slow down in those areas, and that's how you let the LiDAR and let the SLAM technology to acquire those kind of features. And also, not just slow down, make sure you point towards those features, not pointing towards the sky or not pointing towards an area that's empty. So yeah, if you avoid that and then also do it slowly, then yeah, it will definitely improve your scanning result.
And of course, there are scenarios which are very hard to achieve the good scan, like big office buildings with a lot of glass, with a lot of mirrors and shiny areas. So it's very hard for any scanner to achieve the best possible result. And another small tip: if you see the mirror, try to walk with your back to the mirror. So this will avoid that the scanner sees the reflection from the mirror.
That's actually a great segue to our, I think, final question that we can take today from Francis. Will the system work well on tank monitoring? And I'm assuming oil tanks or water tanks, like bigger tanks for storage, especially in the morning when the tank is reflective due to sunlight.
From my point of view, the controlling volume or verticality of the tank needs higher accuracy than SLAM scanner can provide. So you'd better use terrestrial laser scanners for this kind of high accuracy project, and SLAM scanners shine in different scenarios.
Great, thank you very much. I think that wraps up the Q&A session. We do have another question asking about the colorized point cloud results of the P1, which we will be able to share with our sales team to distribute to our customers more from like end to end very shortly. So keep your eyes peeled for that, which will be coming very soon. And we'd like to also remind you that we just launched a new version of the FJD Trion scan, which is now available on both Android and iOS as an app. We do also have a new version of the FJD Trion model software that will be releasing very soon, so also stay tuned for that. Other than that, we are almost right on time. If you have any additional questions, feel free to reach out to your FJD point of contact or send an email to geo.mkt@fjdynamics.com. We will be sending over a recording of this session afterwards, maybe tomorrow or the day after. And then finally, the survey. We appreciate any and all feedback. Thank you very much for attending this webinar. We hope you learned
Thank
lots
you.
and had your questions answered. Hope to see you soon.
Bye.
Bye.